we are going to do about bonding. So last time we're looking at ionic bonding. Hope all your questions and how to answer ionic bonding you got to know how it is done. For those that missed the video or that missed the class, it was simply posted on YouTube. So you'll go on YouTube, you type past chemistry, Uganda, then you'll be seeing that video, how to answer ionic bonding questions and what is ionic bonding. Okay, so in 1 minute still to explain to those that don't know me, because I'm very sure there are some new people that have just joined. So I'm sent here by Past Chemistry and Biology Academy, that everyone knows. What is this academy up to? The academy is up to helping out candidates in their final exams that they are due to do, that is to say the UNEB. So here we handle chemistry and biology. Who is speaking behind the screen? That is Mr. Henry, the tutor of chemistry and biology. Those that want to come into contact with me, this is my telephone here that is provided. Then the other thing, Past Chemistry and Biology Academy has gotten a premium group. In the premium group, that's where we have from our daily lessons or classes. At times, if we don't have lessons, we have discussion of items from different examination boards. So you endeavor to join. If you're interested, you'll see me out to that number. So today we are speaking of covalent bonding. Last time I introduced everything, what is bonding, so I'll not repeat it today. Those that missed, you'll go and see that video. So today we are starting with, or we are going to the next category of bonding, which is covalent bonding. Okay, so many of you might ask yourself, what is covalent bonding? What is covalent bonding? So this is covalent bonding. This is a type of bonding which involves sharing. It involves sharing of electrons between two or more non-metal atoms. It's a type of bonding that involves sharing of electrons between two or more non-metal atoms of elements. So what is the key that we get here? The first key that we get is that this covalent bonding we are speaking about, the first key, the covalent bonding that we are speaking about, is that it simply occurs in non-metals. Okay, it simply occurs in non-metals. And then last time we said it occurs, yes, in any elements, but specifically where? In the atom. So you add that one. It occurs in non-metal atoms. Okay, so that is the first concept we are picking up from covalent bonding. It occurs in non-metal atoms. Okay, so this means when we go to covalent, don't bring anything that concerns metals. It is only going to occur in non-metal atoms. Is that okay? Then this bonding, it also has a different concept for it. It involves the sharing of electrons. Which electrons are we sharing? The ones found in the outermost shell. Now, the electrons that are found in the outermost shell are referred to as valence electrons. Valence electrons. What are valence electrons? These are electrons found in the outermost shell. Okay, so don't be challenged by the word when you see it somewhere. Where you see valence electrons, just know those are simply electrons found in the outermost shell. Okay, so we are saying this involves the sharing of electrons between two or more non-metals of elements. And down here I wrote and I said each atom, or the atoms involved contribute to the bonding electrons. So it is the atoms of these elements that are going to contribute the bonding electrons. That's why I'm telling you that in bonding, it is the atoms that take place. However much it is the elements, but it's the atoms of elements, as you can see here. Okay, so we have some examples. Let's give out some examples. Today the lesson will not be so long. So what are some of the examples? In the examples, we have water. We have water, and water is written as H2O. Written as H2O. Then from water, we have another example, which is carbon dioxide. Carbon dioxide. And this carbon dioxide is simply written as CO2 for the chemistry students around. Let me hope you are not having only biologists here. We are also having chemists. Okay, so these are the sample examples of the covalent compounds that we are speaking about. We have water, where its chemical formula is H2O. Then you have carbon dioxide, where its chemical formula is CO2. Okay, so how do they come to be like that? How do they come to be like that? Okay, so let's see. We are going to start with water. How is water formed? How is water formed under covalent bonding? So first thing first, I said whenever we are going to do bonding, our first concept comes from the atomic number. Okay, so we first know their atomic number. It is the atomic number that will lead us on anything that we are going to do. So you have to first know the atomic number. So we are going to start with the atomic number of water. Sorry, of hydrogen. Why am I saying hydrogen? Because water is made up of H2O. H2O. By H2O, it means it has two components. It has hydrogen and oxygen. Hope you can see that. Hydrogen and oxygen. Those are the two components in water, H2O. So how does it come to be H2O? We are going to start by knowing the atomic number of the two. And we are going to start with the atomic number of hydrogen. From our songs that our teacher gave us, there are very many. Some of you say Happy Henry liked Betty. You'll go there and look for the position of hydrogen. The position of hydrogen is number 1. So its atomic number becomes 1. Okay? Then we go to oxygen. If you're to say out that song or sing it, the position of oxygen is simply the 8th position. So its atomic number is 8. Scholars, hope we are together. We said anytime you are going to deal with bonding, we have to know the atomic number. We have to know the atomic number of the elements that make up that compound. So we have known the elements that make the compound. We have hydrogen and oxygen. Which compound are they forming? It's water. Okay, the compound is water. So we have known that very well. Whereby hydrogen it's 1 and oxygen it's 8. What? The atomic number. So this is how it happens. And even you're going to simply see, how does this H2O come? Why do you write it as H2O? By H2O, I think it is H2O. It means we have 2 atoms of hydrogen and 1 atom of oxygen. But why? Why is it so? So here is the thing behind. So when you're going to draw the central atom here, the central atom here is the oxygen. So you're going to start with drawing the atom of oxygen. And our teacher has told us the first electron have a maximum of 2. Let me change the color for that. Maximum of 2 electrons, that is 1 and 2. Okay, then you go to another orbital For it has a maximum of 8. Okay, but then we have said that the atomic number of oxygen is what? It is 8, meaning if you are tried the electronic configuration here, it is going to be 2 to 6. It does not reach the 8. Okay, then if you are tried for this one, it is going to remain 1. Okay, so implying that this oxygen here, if you are going to try that next, we are going to say 1, 2, 3, and 4. That's the first way we display them. But we have said they are what? They are 6. So you go ahead and add the 2. 1 and 2 to make them 6. This is the oxygen that we have before the bonding with an electron configuration 2 to 6. So it is unstable. Since we said for it to be stable, it should have a maximum of what? Of 8 electrons, valence electrons in the outermost shell. But this one is having 6 electrons, meaning it is missing 2 to be stable. It is missing 2 to make the 8. The 6 plus the 2, they make this 8 that we are speaking about. Okay, they make this 8 here. Hope I'm clear there. So what happens? We said it involves the sharing of electrons. It involves the sharing of electrons. You can see it up here. So this oxygen is going to share its electrons with the 2 hydrogen atoms. That's where they are always 2. It is going to share its electrons or its valence electrons with what? With the 2 hydrogen atoms. 2 hydrogen atoms. 2 hydrogen atoms. That's why you always see them 2 in the formula H2O. But we have said each hydrogen atom has what? Has an atomic number 1. So what will happen? 1 is going to come here. I think let me change the color. Water is blue. Let me use blue. So 1 is going to come here. It is going to attach itself here. Remember, it is sharing, and it is going to contribute its 1 electron. Let me represent it by a blue color. So each 1 electron is going to come here. What is sharing? It is hydrogen. Okay, the other hydrogen will also come on this side where it is not stable. It will also include its 1 electron. I'm symbolizing this by changing color. That 1 electron which is in blue is donated, or is being donated by this hydrogen. Okay, so when we look here, we are going to see that now it is stable when we count 1, 2, 3, 4, 5, 6, 7, 8. Now it is stable. Okay, but it is stable. It has formed a compound that we call water, H2O. So that we go to the conclusion by saying covalent bonding is a type of bonding that involves sharing of electrons between 2 or more nonmetals. You can see that they are nonmetals. Hydrogen is a nonmetal. It's a nonmetal. However much it occurs in many properties. It can be a metal or a nonmetal, but here at this coincidence it is a nonmetal. Oxygen, it is the same. It is also a nonmetal. Okay, hope I'm okay there. So that is what happens in covalent bonding. Hope we are together. So I say today's lesson is short. So let's go and see how do they ask such questions and how do they attempt. You take a screenshot for that. That was water. An example. Let's go and see the ways they ask such questions. So here they are telling us, now another trick when you're reading such questions, you have to be able to interpret. You read a phrase and you interpret. Don't just read it very fast. Okay, so what are they telling us here? They are telling us during a combustion, during a conversion in a cement factory, calcium carbonate decomposes under extreme heats to produce calcium oxide and carbon dioxide. Listen very well. During the conversion, it involves fire, it involves heating. Anywhere you see that word conversion, just know there is involvement of what? Of fire. So during conversion in a factory, which is of the cement factory, calcium carbonate decomposes under extreme heats to produce calcium oxide and carbon dioxide as the products after the reaction. This has left the senior 4 students blank on how this happens and the suitability of the products formed. Now they gave us the equation is here. Now there are other parts on item 2, but I'm now focusing on how to answer the category part. Okay, that's why I'm only bringing for you only part A. So they give us the equation. So this is calcium carbonate. It is a solid. I forgot to put that. Put here the S. It is a solid. It decomposes to give us this calcium oxide and carbon dioxide. Now, of the two, we are going to deal with only carbon dioxide since it is the covalent compound. How do you know that it is a covalent compound? What makes it up? They are non-metals. Okay, then this calcium oxide, for it is an ionic compound. What makes it up? It involves both the metals and non-metals. And in the last class that we had, we did this. Okay, so if you missed and you want us to categorize this, you go to the next video or to the next class posted on YouTube and see how we categorized this. I think this is exactly what was in the question. Okay, so we are going to categorize our carbon dioxide, categorize the products formed. But before I start to categorize, let me first put a highlight. Hope you know that what we have always at the back of the arrow, they are reactants. What we have at the back of the arrow, they are reactants. Then, what we have after the arrow, or where the arrow is looking, they are what we call the products. Okay, let us not be blank with that. I'm sure everyone knows. So we are looking on this side after the arrow, we are having calcium carbonate, calcium oxide, and carbon dioxide. So for us, we are going to categorize carbon dioxide. How do we do that? So we are going to say carbon dioxide CO2. Carbon dioxide CO2 is what? Is a covalent. It's a covalent compound. That's where the first mark comes from. You can even stop there. It's a covalent compound. You can stop there. Now this is category. Remember, on item 2 we mark the category, reason, and example. So here we have already marked our category. It is a covalent compound. Go ahead and give me a reason. Why is it a covalent compound? Why is it? It involves sharing of electrons between what? Between two non-metal atoms. Two non-metal atoms of what? You can stop there, it is okay. But if you want, you can then add two non-metal atoms of carbon and oxygen. Okay, but also stopping here, it is okay. Now here you have given us a reason why you're selecting it to be that. So that is your second mark. This is the reason. Okay, it is a what? A covalent compound. Why? It involves sharing of electrons between two non-metals. Now you further go ahead and give us another example. I repeat, you further go ahead and give us another example of the covalent compound. So you come here down and simply say, for example, you're going to say, for example, another one we have water. Simple like that, and it is done. For example, water. So here, that's how you're going to get all your 3 scores on item 2, part A. If they ask you to categorize, you give the category, the reason, and the example. Hope we are clear and you have understood. Yes, so thanks for joining the lesson. Endeavor to take the things that I've spoken about seriously. I remain Henry, a tutor of chemistry and biology from Past Chemistry and Biology Academy. This is how you're going to get me. That's my number, my contact. If you like to join the premium group, of which now it is going to be effective for this next term that is starting, since holidays are soon closing, you contact me there. We see how you join the lesson. Nice time, scholars.